A sequence is a set of numbers in a particular order or pattern. So we're focusing on patterns in this unit. Patterns of numbers. Numbers, they add the same thing. They multiply by the same thing. It's like 2, 4, 6, 8, 10. Patterns. What does the word infinite mean?
Just don't stop.
It doesn't stop, right? An infinite sequence, so a sequence, a list of numbers, it's a sequence that never ends. So if I want to start with a pattern of numbers, let's say I start with 5, 7, 9. What would go next? 11. How could I show, without actually just sitting here for the rest of my life writing numbers, how could I show that this goes on forever?
Dot, dot, dot.
Exactly. Dot, dot, dot. So if you're asked, is this sequence infinite or not? Look to see if it has those 3 dots at the end. Those 3 dots means whatever pattern was going is going to continue forever. A finite sequence is the opposite. It contains a limited number of terms. So it doesn't go on forever. There's just only a set amount. There might be 5,000 numbers in the list, but then it stops. So this same pattern, 5, 7, 9, 11, I could stop there, but I might try to trick you, and I might put dot, 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 75. This is still a finite sequence, even though it has 3 dots. Those 3 dots weren't at the very end. This means this pattern continues until it hits 75, and then it stops. That just kept me from having to write all those numbers in between. So do you see the difference in these two?
Yeah.
One has the 3 dots at the end. One actually has a stopping number. When you have a list of numbers, every number we refer to that as a term. So the first number in the list is the first term. The 7th number in the list, we would call that the 7th term. And you see that written, you'll see a lowercase a and then a little n down there. That n could be any number. So, for example, a with a little 1 is the first term. A with the little 2 is the second term, and so on. So if it says A5, we want to know what the 5th number is in the list. And so AN is just in general. N could be any number. So I have a list 1, 5, 9, 13, 17, and so on. What is A1 in this list?
The first term.
Which is what?
1.
1. The first, so A1 is the first term. The first number in my list is a 1. What is A4? 13. Like this is A1, A2, A3, A4, A5, and then that pattern continues. I just stopped writing the numbers. So see if you can figure out what A10 would be.
If I got it right, I think I got 32.
Write down what you think. You can compare with someone sitting near you. I wouldn't just try to count them in my head. I would write out the numbers until you have 10 numbers. Otherwise, you might miscount and have one too many or not enough. Riley, what did you get?
34.
You got 34. Does everybody agree?
Not one bit.
No? Alright, well, let's see. If I continue my pattern, well, what am I adding every time? 4. I know what you did. Did you just take the 5th term and times it by 2?
Yeah.
Yep, you can't do that. So what he did was he saw, okay, well, the 5th term is 17, so the 10th term is twice that. So can't do that because of this 1. Okay. So if I continue the pattern, I would have 21, 25, 29, 33, 37, 41. And so this would be a 6, a 7, a 8, a 9, a 10. So it's actually 37. Number 1, these directions just say find the next 3 terms in the sequence. You got to figure out what the pattern is and then write the next 3 numbers. I want you to try those.
Wait, what did you say?
Figure out what the pattern is and then write down what 3 numbers would be next for each of these. Who thinks they know what the pattern is in number 1? Riley?
You times it by 2.
It's multiplying by 2. That's the basic one that's happening.
Seriously.
Yeah. So, and it's a positive 2. You see these negatives, that can be a little confusing, but negative 1 times 2 is negative 2. Times 2 is negative 4. Times 2 is negative 8. Times 2 is negative 16. So then if I continue, times 2, I get negative 32 times 2, negative 64 times 2, negative 128. So those are the next 3 terms. What about the pattern in number 2? Who thinks you know that one? Adding 5, right? 31 plus 5 plus 5. So what is 51 plus 5? 56 plus 5. 61 plus 5. 66. There's no set way that you always check to find the pattern. Sometimes you just have to play around with the numbers, try adding and subtracting different things, try multiplying. What about the pattern for number 3?
It goes up by 2 each time. So you add 2 to the number that is going up by.
Yeah, so if you start looking, now your first instinct might be, oh, 3 times 2 is 6. But then 6 to 11, you don't multiply by anything, that wouldn't work. But 3 plus 3 is 6. Plus 5 is 11. Plus 7, hold on, is 18. Plus 9. So notice it's 3, 5, 7, 9.
I know you can do it like that.
You could. So the number that you're adding is going up by 2. That's a tough one. So what number will I add next? 11. So 27 plus 11, 38. So I added 11, then I should add 13. 38 plus 13, 51. And then I should add 15. So I added 11, 13, and 15 to get 66. Now, every pattern has a formula that goes with it. So I could write all of those 3 that we saw in the 1, 2, and 3. I could come up with a formula that helps you find any of those. You're going to be doing that later on. But for right now, I'm going to be giving that formula to you. So an explicit formula allows you to find any term of a sequence. Sometimes we refer to this formula as a rule. So I might say write the rule, or find the rule, or find the formula. But in number 4, I'm telling you, now your formula will always be like AN equals something. AN just means any term in the sequence. Comes from that formula. So number 4, I have AN equals 7 times n plus 3. That's the formula. I could find any term I wanted. I'm asking you to find A3. That's the third term. Your n is 3. So I want to know what is the third number in the list that corresponds with this pattern. And all we're going to do is put a 3 in the n spot. So A3 equals 7 times 3 plus 3. And you can type this straight in the calculator. And you should get 42. You don't type in the AN part, just the numbers after the equal sign. And you get 42. So the third number in this sequence is 42. Number 5. Here's my formula. That n plus 1 is in the exponent, so be careful. I'm asked to find A1. That's the first term. N is 1. So A1 equals 2. And then it says n plus 1 in the exponent. I'm going to do 1 plus 1. That's really 2 to the second power. 1 plus 1 is 2. What is 2 squared? 4. So the first number in that list is a 4. Try number 6. Here's my formula. We're asked to find A7. That's the 7th term. A7 is the same thing as the 7th term, which means my n is 7. So I'm going to rewrite this, but put an n, or put a 7 for n. So A7 is negative 4. And then 7 squared. And you can just type that in your calculator.
How do you do AN in your calculator?
You don't. You just put what it's after the equals. So negative 7, or negative 4 times 7 squared. And you should get negative 196.
How you square it? The x2, right?
Yeah, or this button right under the clear will let you type anything in the exponent. Seven, 8, and 9 are a little different. I give you the formula, but then I give you a different piece of information. I say AN equals 20. So I'm basically giving you backwards from these three. I'm telling you that 20 is one of the numbers in the list. I just don't know how far down the list it is. if you are asked to find n, is 20 your n?
No.
No, if I ask you to find it, 20 is not your n. Do not put a 20 in the n spot. This says an equals 20. So I'm going to put a 20 in for an. I'm going to put a 20 in the front. So I'm not going to plug a 20 in the n spot. It's going to go for an. Because it says an equals 20. You can replace those. This is 20 equals 2n plus 4. And we have to solve this equation.
You wouldn't put each one? So you have to.
Do what?
You wouldn't put each one?
No. The whole an equals 20. So this whole thing equals 20. And so I would subtract 4 from both sides to get 16 equals 2n. Then what?
Divide by 2.
Divide by 2. So 8 equals n. So what this means is that the 8th term is 20. The 8th number in the list is a 20. So number 8, I'm giving you the formula, and I said an equals 45. So we're going to put this 45, we're going to replace the an, the whole an, with 45. And we have to solve for n. What would you do first?
Wait. Is n and an different?
Mm-hmm.
They're the same thing?
No. N, you have n, you have an. N is the number of the term. So like, if here's my pattern, 3, 5, 7, 9. My n is 1 here. My n is 2. My n is 3. My n is 4. So n is like how far down the list it is. And then here I would say a 1 equals 3. A 2 equals 5. A 3 equals 7. A 4 equals 9. So an is saying this number up here, the 3. So if you're solving this, what is your first step? Distribute. Okay. So nothing happens to the 45. 5 times n, 5n. 5 times negative 3, negative 15. Then I'm going to add 15 to both sides. We get 60 equals 5n. And then divide by 5. 12 equals n. So what that means is that the 12th term is 45. The 12th number in the list is 45. And then the last one, my formula is n squared plus 1, and that says an equals 26. So I've got to do 26 equals n squared plus 1. What should I do first? Subtract 1. (25) equals n squared. How do you get rid of a squared? You square root. Very good. So to get rid of a squared, you do the square root. And what is the square root of 25?
5.
It is 5. So what that means is that the 5th term, or A5, is 26. The 12th term means A12. The 8th term is A8.